Today, we are starting something that relates to rational functions, but it might not seem to at first. So first of all, I need a show of hands. Who here has ever run track or cross country sometime in your life? Okay. Zach, can you tell me your fastest mile time? You don't, like, just like sometime in your life, the fastest mile time that you remember. 5:38. I will use 5:38. 5:38. That is pretty fast. That's faster than anyone in the last class. So 5:38, I'm going to round that to about 5.5 minutes. So it'll be, I want a nice number for the purpose of this. So if we say we can run a mile in about 5.5 minutes, my mile time is 12 minutes. I'm very proud of this. So, if Ryan and I decided one day that we're not going to run a race, we are going to work together to cover 5 miles. So we're going to start at the same time, and we're both going to run for the same amount of time. But that amount of time that we run will stop once we have collectively run 5 miles. So if I just look at these times, am I going to run more miles than Ryan? Definitely not. So what we're trying to find is collectively we will run 5 miles together. We want to know how much time it would take for us to run those 5 miles collectively. So with the people around you, groups of 2 to 4 people sitting directly around you, you need to try and figure out how many minutes would it take for us two to run 5 miles collectively. I will pause the recording while you attempt to solve. Now we've had a little bit of time. If we look at this, show of hands, how many people are confused, don't even know where to start? Me. I'd be confused. I looked at this. We had to do a problem like this in college for my education class. And when they first gave it to us, I was like, I don't know. I remember doing something like this once, maybe in high school. So, what we are doing here, if you think about it, if you know that you travel 1 mile in 5.5 minutes, what does that remind you of? A mile in minutes. Miles per hour. Miles per hour? That's like miles divided by hours, right? Does anyone remember what this kind of term is called? Miles per hour. Meters per second. It is a rate or a ratio. So what kind of rate are we using in this problem? We're going to be using miles per minute. And let's say Ryan is the first person. So we're going to look at the rate for Ryan. And what is the rate for Ryan? Exactly. So we have 1 mile in 5.5 minutes. Hold on 1 second. So now we have a rate for Ryan. Do we have a rate for me? What's my rate? 1 mile in 12 minutes. Okay, so we've got these 2 rates. But what do we want to find out? Eventually, we want to figure out how much time it would take us to run 5 miles together. So if we are running together, and we know that we want to run 5 miles, and we want to find the amount of time, now we have 3 different rates. If we have these 3 different rates, how do they relate to each other? If I have this rate here, and I have a rate here, and I have another rate here, these 2 rates will add up to give me the last rate. I like this equation. Rate plus rate equals rate. That makes sense. Okay. More importantly for us, though, we want to be able to figure out what the rate is. Right? If we have a rate, typically rates miles per hour, meters per second. Here we have miles per minute. But couldn't we also have something like, if I have a chicken, and the chicken lays eggs, and it lays an egg every half an hour, what would my rate be then? It would not happen. It would be a lot of eggs. But what would my rate be? It'd be eggs per hour. That would be our rate, right? So in general, if we have a rate, we want to make sure that we set up our rate as a rate is equal to whatever our objective is. So for us, that might be miles, or it could be eggs, or it could be pizzas, or carrots, or whatever you want it to be. We have our objective, and it's divided by some kind of time. The way that I like to remember this is R-O-T, rot. And if you have something that's rotting, that means that you have to be under the ground, so you know that there's a division sign. I don't know. That's how I remember it. You can remember it however you would like. But a rate is just some kind of objective over a period of time. So if we look back at our problem up here, we have 1 mile per 5.5 minutes plus 1 mile per 12 minutes is equal to 5 miles in some X number of minutes. And now we need to solve this. If we want to solve this, what would our first step be? Come and talk with your table partner. What would the first step that we have to do be? You have turned and talked. If you ever turn and talk with the neighbor, and both of you are like, I don't know, why don't you just go and turn and talk with other neighbors too? Maybe you have some other neighbor around you that knows what's going on, or has an inkling of what to do next. Okay. I'm going to quickly rewrite our equation down here. We have 1 mile over 5.5 minutes. We have 1 mile over 12 minutes. And we have 5 miles over X minutes. Row 6, person 5. Could you tell us what would be a good first step?
I don't know, we did it a different way. We still think we got it right. So I'm going to piece this to just look actually.
Okay.
Or else we think we got it
Okay, yep. Maddie. We could multiply by x. Why would you want to multiply by x? Yeah, don't we want x in the numerator? Just in general, don't we like just not want denominators? I don't know about you, but I hate having fractions. How could we just get rid of these fractions? We could multiply them by the reciprocal. What I'm going to do here is we have a 5.5 and we have a 12. If I wanted to add these two fractions, how would I add these two fractions together? That would be the first thing I would need to do. Adding fractions. What do you think, Greta? We do need a common denominator. If we need a common denominator, we have 5.5. What is that as a fraction? 11 halves? So this is like 1 over 11 halves. How could we rewrite 1 over 11 halves as just one fraction? This just becomes 2 11ths. So all we did is we said, oh, if it's 1 over 11 halves, that's the same thing as 1 divided by 11 halves. So if you just multiply that by the reciprocal, that's the same thing as saying 1 times 2 11ths. So we got 2 11ths. So we have 2 11ths plus 1 12th. And now we need a common denominator. So what should we multiply each of these fractions by? We have 11. You're fine. So if we have 11 here and we have 12 here, do they have any common factors or common multiples? Yes. We need a least common multiple. Or you just multiply them together, right? If you have 11 and you multiply the bottom by 12, what do you have to do to the top? Also multiply it by 12. If we multiply the top and the bottom both by 12, have we changed the fraction? We have not. So that's why we are multiplying both the top and the bottom by 12. And then over here, if we multiply the top and the bottom by 11 instead, then in the numerator, we'll have 24. In our denominator, we'll have 132. And then likewise over here, we'll have 11 over 132. And once we add these together, we have 35 over 132. You might be wondering why we're doing this entire process. You might have found another way that you think works, and it probably does work, okay? But at this point, I am showing you this process just in case you do not have a process and have no idea how to address this problem, okay? At this point, we've basically combined these two fractions together to create one fraction. And we know that one fraction is still equal to our 5 miles divided by our x minutes. If we have one fraction equal to another fraction, what can we then do? We're trying to solve for x, and I heard it. We gotta cross multiply. If we cross multiply, we'll end up with 35x and 5 times 132. I have no idea what that is. I'm going to quickly type it in. Times 5. 660. And then, if we divide both sides by 35, we end up with 18.85 minutes, about. So if you were able to get to 18.85 minutes, and you found a way that worked, good for you. If you were not able to get to 18.85 minutes, but this method makes sense to you, good for you. if you are still completely lost, this is what we are learning today. So we can continue to practice. I would like a show of hands. Who here is like, okay, I got this. I don't need to do any more practice on this. Who here is, I might want a few more of these problems to practice on my own. And I would like a few more problems that we go through together because I'm completely lost. I need everyone to have one of these 3 thumbs. Okay, looks like majority just want another practice problem so that to do in your groups. Okay, so here's actually a true story. Who here knows about the competitive sport of eating? Okay, at the beginning of last period, I was like, man, people who can do like eating competitions, they're my heroes because I wish I could eat as fast as them. And then we watched a video clip of people actually doing an eating competition, and then I said, I changed my mind. I never, ever want to see another eating competition ever again. So I don't know if I can bring myself to show that clip today. Maybe I will show that clip. But there was a hot dog eating contest in 2014, and there were the first and second place people whose last names were Chestnut and Ernie were able to eat hot dogs in a specific amount of time. See if you can figure out this one by yourselves based off of what we just did. And I will give you time to do so. We've had some time on this problem here. Are you watching the video? Well, at this point, just checking in with everyone to make sure that we have all the same number. All the same number. Caroline, did you get an answer?
Yeah.
Could you?
Rounded up, I got
5.5 minutes. Show of hands, I got 5.5 minutes, or like 5.45, I believe. Awesome. Yes. Okay, so we got 5.5 minutes. Is there anybody who would like me to go through the process of solving this? Okay. Because we have just a few people, I will have a small group in the front for people who would like aid on the next problem. I would like you to do one more. Okay? One more. Try this one by yourself, not with partners. Try it by yourself. We've done a few with partners. If you would like some aid with this, let's have a mini session. Okay. I will pause while we mini session. Looking at the homework, because I already assigned it last period, and that's not fair. Okay, looking at the homework, problem 1. You can just remember these numbers. Problem 1, problem 25. Or problem 1 and the llama problem. Those are the only 2 you have to do. I would strongly recommend doing them tonight. Strongly recommend. I did not. Okay, that is all we are doing for now.